This is day 42 of 50 days of tutelage. So this class is going to be a very soft one because I'm not doing any calculation. It's just on metals and their extraction. Then I'm just going to explain some basic things. Some of these things I've mentioned them in previous classes. So just to reiterate them, and then the class ends. So let's get right into it. So the first thing we'll talk about is the occurrence of metals in nature. So what we notice is that most of these metals that we talk about, aluminium, sodium, potassium, copper, silver, and all of them like that. Yeah, in the reactivity series, we just mentioned them like that by their name. We just, talk about metals. We say they are very reactive. Well, we say they belong to the left side of the periodic table. But their discovery, do we actually always find them that, oh, after digging through the earth in some, to some depth and all of those things, you just say, oh, I've discovered aluminium, or you just say, I've discovered sodium and all of those things. It appears that it does not always occur like that. The way they occur is such that some of them occurs freely. But some of these metals, they are very, very reactive, such that wherever you find them, wherever they are, when they are exposed to the atmosphere, they tend to become something else. That is, they form compounds. They form compounds instead. So if you're going to discover aluminium now, you most likely will not discover it as aluminium. You will discover it as it forming a compound with something else. That is, they undergo chemical reaction upon exposure to the earth, to the atmosphere, or to the surrounding. So that is why, because of their difference in reactivity, they are found in the earth crust in different manner. So very unreactive metals like these guys, gold, platinum, and silver, they occur freely in nature. So these ones now, you can easily just extract them and just dig them and just find them roaming around freely. Why? Because they have very, very unreactive nature, and so therefore they don't react to oxygen, they don't react to water or acid in the environment. So, but for the ones that are reactive, from moderate to the highly reactive ones like iron, aluminium, zinc, copper, sodium, these ones, they always, I've talked about this already, they always occur as compounds. So either they are occurring as oxides, like aluminium oxide, or they are occurring as carbonate, sodium carbonate, or they are occurring as sulfide, or they are occurring as silicate. So, and this is because they readily react with substances such as oxygen and carbon dioxide, sulfur, and so much like that. So they react with all these things. And because these guys are just there, present in the earth, and they are present in the atmosphere, so these metals easily react with them, and therefore you don't just find them lying around with on their own without being combined with something else. So we talk about, we have a mineral and we have ore as well. So ore is actually where we extract metal from. So if you read what I wrote here, a mineral is a naturally occurring compound of a metal or element found in the earth's crust. But if it's a ore is a type of mineral from which metal can be extracted. So if you can extract metal from it, then it becomes a ore. So we have a mineral ore. And I've given some examples here, some common ones. So aluminum has its ore. So the ore of aluminum is bauxite. You need to pay attention to all these things very well. Bauxite is majorly aluminum oxide. Yeah, this is just showing that it has water of crystallization. But and in the form of extracting aluminum, actually, this is one of the first things that we take care of in that place. We kind of dry the moisture part away before we go to the process. And I think I've mentioned this when I was teaching electrolysis. You can actually use electrolysis to extract this aluminum from this place. We'll talk about that later in this class. Iron, the ore of iron is hematite, and then you have this chemical formula. So I've given all of them here, because we have iron 2 and we have iron 3. In this place, we have iron 2. In this place, we have iron 2. And in this place, we have iron 3. I think I've been able to explain the variable oxidation state for transition metals. And this one, we have zinc blend. This is zinc sulfide. We have copper pyrite. So that is a complex ion, actually. You have copper, you have iron, and then you have sulfur as well being formed together. You have brine, NaCl. I think this one is very, very common. You have when you get seawater, yeah, some seawater. I think it's called salt water, whichever one it is, ocean water rather. So they when you extract this guys, you get salt out of them. So if you boil seawater now and you evaporate everything, then you get salt from there. The salt from there, you can actually extract sodium from there. You can do the electrolysis to extract sodium actually. And we have lead. The ore of lead is galena, and that is lead sulfide. So that's you need to be familiar with all these things actually. Let's go further. So what are the stages that are involved in metal extraction? The first one is the concentration. So what is that actually? Because like I said, they are probably buried in the earth somewhere, or they are in the ocean, or all of those things. So you remove rocky waste, so you can do it by flotation, so that all those sandy whatever can separate from them, or gravity separation, or magnetic separation. Magnetic separation, gravity separation, these are methods we use in separating solid from solid. I think I explained the concept of separation technique in our previous classes. So these ones are just like, let's say a particular ore is buried in depth, is buried in debt. So you want to extract the debt away from it. So that's what the first one. So you concentrate it, you kind of isolate it outside, and then conversion to oxide. We like to always convert them to oxide because you can easily reduce oxide. When I was teaching about redox reaction, oxidation and reduction, I spoke about the fact that addition and removal of oxygen, they both define oxidation and reduction respectively. Now, when you have oxides are easily reduced because the moment you bring a reducing agent close to it, that reducing agent will become oxidized. So if you have an oxide, so you have an oxide here plus a reducing agent. So what happens is that this reducing agent becomes readily oxidized, and therefore you can get this guy alone. So we convert them to oxide. So sulfide or carbonate ores are converted to oxide by roasting, heating them in air, or by calcination, which is heating in limited or no air. Since oxide are what? They are more easily reduced. So then we go ahead to reduce. Mostly we reduce by coke actually. The metal oxide is reduced to free metal using an appropriate reducing method. Yeah, I will talk about this later. Mostly we reduce by coke, that is carbon. But there are some guys that we cannot reduce by carbon. I will still explain the difference between them very soon. Then the last stage is always the refining stage, which is the purification to make sure that it is a pure metal. The crude metal is purified to the degree of purity required. So I'm going to explain all these things now. So let's talk about extraction method and the reactivity series. So how do we determine what extraction method we want to use based on the reactivity series? So we have very, very reactive metals like potassium, sodium, up to aluminum like that. These ones we use electrolysis of their molten compound. So when we get to the extraction state, we always, so that's why I was talking about this one earlier, aluminum oxide and the likes. So we can do them by what? By electrolysis. We can extract the metal by what? Electrolysis. So these ones are very reactive. Electrolysis of their molten compound. So example is this guy. So can you still remember what the name of this guy is actually? That's your bauxite. Bauxite. And this one is brine. Brine. So let's go back so that you can check that. So aluminum, the ore is bauxite. And then for sodium, okay, I didn't include sodium here, but I think I mentioned it somewhere as I was explaining. So for sodium, okay, yes, it's here. Sodium is brine. So familiarize yourself with these ores of these different metals. You can be tested about them. And so we have the moderately reactive one from zinc to lead. This one, you use chemical reduction by carbon or carbon monoxide. So you reduce them with carbon or carbon monoxide. So for example, you can reduce iron in blast furnace using this guy. Then you have the less reactive one. You can just heat them. So once you heat them, they are actually like separated. So this copper is separated from sulfur just like that. And then for the least reactive one, you don't need any form of extraction because they occur freely. Physical separation like flotation, once those methods are used to separate solids from solid. So that's just basically so like panning and gravity separation because they are only stained by maybe let's say mud or something else. They're not really they don't really need extraction like that. And then so these are some few examples. Extraction of iron from the blast furnace. So let's go through the process. These are the things we need. We need the ore itself, the hematite, and then we need coke. and we need limestone and hot air, definitely. So coke will burn to form carbon 4 oxide. So you combustion of coke to form carbon 4 oxide, and then you introduce excess coke, which is reduced by more coke. So you introduce excess coke to this guy, and you have your carbon monoxide. Now, this carbon monoxide is the main reducing agent, not CO2. Also, yes, this is carbon 2 oxide. I've explained this one when I was teaching you about chemical compounds, chemical combination and likes. How this one is called carbon monoxide, but it's also called carbon 2 oxide. And how this one is called carbon dioxide, and this is also called carbon 4 oxide. I've explained all of that in the previous classes, so you can check the playlist to, to see. Now, this carbon monoxide is the reducing agent. You react it with the hematite and it extracts the iron from it. So limestone decomposes and removes the sandy silica impurities as molten slag. So this guy still contains some impurities. So your limestone, which is your CaCO3, yeah. So CaCO3 decomposes. So you have CaO, and this is your quicklime. So the quicklime turn this guy into what? Slag, because this will still be an impurity somewhere around this whole extraction. So you can remove this thing as a slag. Slag can easily be precipitated away from the whole process. So molten iron collects at the bottom of the furnace and is tapped off. The slag floats above it and is removed separately. The product is called pig iron, cast iron, and contains about 4% carbon and other impurities. But at least it's pure enough. We have extraction of aluminium. I'm not going to be explaining too much about this because I've explained the process of extraction using electrolysis. But the process is called Hall-Héroult process. The first thing you do there, which is like to remove this water of crystallization. So bauxite is first purified to pure alumina by the Bayer process because aluminum is high in reactivity series. It cannot be extracted by carbon reduction. So when they are high in the activity series, so you can see that those guys that are high in activity series, carbon reduction is not a best option for them. So those that are moderately reactive are the ones that we use carbon reduction to do them. So yeah, pure aluminum has a very high melting point. So I've explained all of this one under electrolysis. You can easily check them out. The aluminum is just going to be at the cathode and it is going to gain electron and therefore becoming aluminum. Then we have extraction of zinc. So the first thing, you concentrate it by froth flotation, then you roast it in air to convert it to zinc oxide. So this is the equation of the reaction. Then zinc oxide is then reduced by coke. So because zinc is moderately reactive, it can be reduced by what? By the action of coke. So, and then you have your zinc and you have your CO extracted in that place. Now, it has a low boiling point. It is obtained as a vapor and condensed to liquid solid metal, or solid metal rather, which may then be refined by fractional distillation. So let's talk about the refining process. The refining process, purification of metals. So you can do electrolytic refining. In this case, I told you that whenever you want to purify metals, I've taught you under electrolysis that you make the metal you want to purify, you make it the anode. Of course, both of them will be the electrode. You just make it the anode. And then there will be dissolving of this metal into solution. So you have a construction of this nature. So let's say I want to purify zinc now. Zinc is here. Then the solution will also be a salt of zinc. It can be zinc sulfate. Then the anode will actually dissolve into solution. So the impure metal is made the anode and a thin sheet of pure metal the cathode. So they are going to be the same metal for anode and the cathode. Then in a solution of the metal salt, so I've explained this already, pure metal deposits on the cathode used for copper and aluminum. So how does this pure metal deposit on the cathode? It's actually going to be, first of all, the anode dissolving into solution. When it now dissolves into solution, the concentration of Zn2 plus will increase. I'm just using zinc as an example now. Of course, major one here are copper and aluminum. So the concentration of zinc Zn2 plus increases in solution, and so therefore it migrates to the cathode and therefore it becomes deposited. So you have something of this nature, Zn2 plus, it gains 2 electrons and become zinc. So with that, you're purifying it like that. Then you have the fractional distillation. This is used for low boiling point metals such as zinc and mercury. That is, those ones that can actually be in liquid form, like liquid metal. And that's basically the summary on metals and their extraction. So that will be it for today. I'll see you in the next one. Don't forget to like and subscribe to the channel as well. All right.